Hi students, in this video we're going to be talking about the domains of functions and computing some examples where we calculate the domain from a table, from a graph, and algebraically. So the domain of a function is just the set of all the values for which the function is defined. So another way to think of this is it's a bunch of x values so that have y values attached to them. That's what it means to be defined. So another question is, which x values have y values or outputs associated with them? And sometimes it's easier to ask the question, which x values don't have y values or outputs associated with them. We'll see some examples of that too. So let's first compute some examples where we are using a table, a function table, or a graph to compute the domain. Excuse me. So here's our table. These are inputs and these are outputs. You'll notice that the number -2 doesn't appear in the table. So what that means is that we don't know what the output for -2 is. There's no output associated with it. That means that -2 is not part of the domain. The only elements that are part of the domain, or the only numbers that are part of the domain, are these numbers for which we know the y value. So the domain will be the set of -3, -1, 0, 2, and 4. So one way to think about this is just for which values, so another way is for which values of x do I know f of x? So from this table, we could do f of -1, that's going to be 4, but if we try to do f of -2, we don't know, so -2 is not in the domain. And the same principle applies to this graph. So if we look at this graph, I could tell you f of -3, if I had some bars here, it's whatever this y value is. I could tell you f of -2, I could tell you f of -1, I could tell you f of 0. So far, all of these x values are in the domain because they have a y value attached to them that you get by just looking vertically to see what the y value of that point, of that coordinate is. So we use interval notation to write this. I know from -3, at least up until 1, that's in my domain. Then I have an open. But at the value 1, I have a y value attached, so 1's actually in my domain as well. And then all of these x values between 1 and 3. But I have an open circle and an open circle in the graph above 3, so 3 is not in the domain. But then all the x values between 3 and 5 have y values attached to them. So since I actually did include number 1, I can combine both of those intervals. So I have the interval from -3 to 3 open and 3 to 5. And 5 should be closed because at 5 I can evaluate the function. So to find the domain from a graph, all you do is you look at which x values have y values attached. And we often write the domain in interval notation. If there's an open circle or a gap in the graph, that indicates that you have to leave something out of the domain. So since there's an open circle above 3, we had to leave the number 3 out of our domain. Now let's do some algebraic examples. These you may have seen some algebraic examples of computing domains before. And this is where we want to ask the question, which values for x cause trouble, or don't let us evaluate the function. So when are we going to have trouble with this function? Well, we know we cannot divide by 0. So the rules we're going to follow are we cannot divide by 0 as our first rule. So since that's the case, we have to say, since x plus 5 does not equal 0, that means that x cannot equal negative 5. In other words, g of negative 5 is undefined. If we try to plug in negative 5, we have a problem. So what that means is that negative 5 is not in the domain. But any other value for x is. Think about it. Any other value for x, I'm not going to get a 0. I can divide by any number except 0. So we can say the domain is all real numbers except 5, or except negative 5. And that's our answer. Another example, here we have a square root sign. So what can go wrong with the square root? Well, we're not dealing with imaginary numbers, so we can't have a negative number under the square root. We can have 0. So since 4 minus 3x must be greater than or equal to 0, we can just continue to solve this equation for x. So we want to get an inequality that involves x. So I'll bring the 3x over to this side by adding 3x to both sides. And now I divide both sides by 3. So 4/3 has to be greater than or equal to x in order for this function to be defined. So this is the domain. And now let's just check some values. If I were to plug in something bigger than 4/3, then, so say I want to do gh of, let's do 2, then I'd get the square root of 4 minus 6, which is the square root of negative 2. So that's bad, because I'd be taking the square root of a negative number. 2 is not in the domain, which we knew because 2 is bigger than 4/3, and our x values need to be smaller than 4/3. But if I take a smaller value, say 1, then I'm doing the square root of 4 minus 3, which is the square root of 1, and that's okay. So this is bad. Since 2 is bigger than 4/3, this is good, since 1 is less than 4/3. 2 more quick examples. Now I have a function that involves 2 different fractions. So I can use this idea that we cannot divide by 0 twice on each fraction. So our first one tells us that x cannot equal 0 because I can't divide by 0. The second one tells us that x cannot equal negative 2. So now when I write my domain, I just have to combine all of these. So it's all real numbers except 0 and negative 2. And finally, in this last example, I have a fraction and I have a square root in the fraction. So I have 2 different rules to satisfy. X minus 10 has got to be bigger than or equal to 0 because I can't take the square root of a negative. And x minus 10 the square root of x minus 10 cannot equal 0 because I can't divide by 0. So this first rule tells me that x is bigger than or equal to 10 in order to be in the domain. The second rule tells me x cannot equal 10. So now if I combine what I learned from each of these rules, I know that x must be strictly greater than 10. If I try to do a of 10, I'd get a 0 in the denominator. If I try to do a of 9, something which is smaller than 10, not in the domain, then I get a negative number under the square root side. Okay, so here are some rules that will help us remember how to find the domains of functions. So we want to exclude any value for x which gives a 0 in the denominator. So say we had anytime we have a denominator, you could think of this as one function over another function. We need f of x, the denominator function, to not equal 0. And you just would solve for these x's. Also, if our function is under square root sign, then we can't have it be negative. So we want to figure out all the values for x which make g of x greater than or equal to 0. So those are the ways that we approach it. We find the x's which make it equal to 0 in the denominator and we leave those out. And if we have a square root sign, we find the x's that make what's underneath the square root sign greater than or equal to 0. I hope that these examples help. Let me know if you have any questions.